we're going to explain Python socket connection timeouts. Network operations, especially socket connections, can sometimes take a long time to complete or fail altogether. Imagine trying to connect to a server that's down or experiencing network issues. Your program would hang indefinitely if it didn't have a way to handle this. That's where timeouts come in. They let you set a maximum time for a socket operation, preventing your program from getting stuck. Let's explore how to implement this in Python. 1. The socket.setTimeout method. This is the core function for managing connection timeouts. It takes a single argument, the timeout value in seconds. A value of 0 means no timeout. The socket will block indefinitely, while a positive value sets a time limit. For example, sock.setTimeout 5 will make the socket wait up to 5 seconds for a connection or operation to complete. If it exceeds 5 seconds, a socket timeout exception is raised. You should handle this exception in a try-except block to gracefully deal with failed connections. 2. Handling socket timeout exceptions. It's crucial to wrap your socket operations in a try-except block to catch socket timeout exceptions. This prevents your program from crashing when a connection takes too long. Inside the except block, you can implement logic to retry the connection, display an error message, or take other appropriate actions depending on your application's needs. A simple retry mechanism with a small delay might be implemented here. 3. Implicit timeouts with connect. The socket.connect method itself doesn't directly take a timeout argument. However, the timeout set using socket.setTimeout applies to connect as well. If the connection attempt exceeds the set timeout, a socket timeout exception will be raised. 4. Setting timeouts for other socket operations. The socket.setTimeout method applies to all socket operations, not just connect. This includes recv, send, and other methods that might block. If any of these operations exceed the timeout, a socket timeout exception is raised. This ensures consistent timeout management throughout your network interactions. 5. Best practices. Consider setting reasonable timeout values. Extremely short timeouts might lead to frequent timeouts even on healthy networks, while overly long timeouts will keep your program stuck for extended periods if a connection problem occurs. Choose a value that balances responsiveness and robustness for your application. Always handle socket timeout exceptions gracefully to provide a better user experience and prevent unexpected application termination. Finally, always close your sockets using sock.close to release resources even if a timeout occurred. In short, using socket.setTimeout and correctly handling socket timeout exceptions is vital for writing robust and responsive network applications in Python. By adding timeouts, you avoid indefinite blocking and make your programs more resilient to network issues. Remember to choose appropriate timeout values and gracefully handle potential exceptions.